There was a time when the dining room was for formal dining only, and the style of dining room furniture reflected that. Not anymore. Today's dining room sets come in both elegant and casual styles, and there's something to suit every decor, from contemporary to country, from traditional to ultra-modern. This factory makes casual dining room furniture. It uses only durable hardwoods, such as birch and beech. It buys the parts pre-made from a supplier. The workers here assemble the pieces and finish the furniture to the customer's specifications. We're going to see how they make tables. The parts arrive already sanded, but they still go through a machine that gives them an additional fine sanding. This prepares the wood for staining. Workers sand the solid wood parts for the apron by hand. The apron will go just under the tabletop. Workers closely inspect all the components under fluorescent light. They look for any flaws in the wood that they might have missed during sanding. It's critical that every imperfection be sanded down. Otherwise, it'll show up as a glaring defect once they stain the wood. After all the parts pass inspection, assembly can begin. First, they remove the tabletop's extension piece called the leaf. They make sure the two main sections fit together perfectly. Then, using a template to ensure the exact positioning, they screw on the runners, the sliding mechanism for extending the table. Then they mount support pieces called stretchers. After marking the position of the apron, workers screw in steel braces to level and align the three sections of the table. This table will have a pedestal base rather than four legs. After installing a part called the assembly plate, they lay down a series of metal templates. These ensure that they mount the apron precisely. Now that they've finished assembling the tabletop, they check its stability and test the mechanics. If everything's up to par, the tabletop moves on to the finishing department. The factory buys wood stain from a supplier. To ensure that the colors are consistent from table to table, the factory tests the stain before using it, comparing it to a color sample. This staining operation takes place in the part of the factory known as the paint kitchen. Each tank has a mixer inside to keep the stain well blended so that the pigments don't settle to the bottom of the tank. This ensures the color will be consistent. There's a separate spray gun for each stain color. After spraying the stain onto the tabletop, a team of workers quickly wipes off the excess. They have just 30 to 90 seconds, otherwise the shade will be off. Another inspection under fluorescent light. Any flaw in the wood they missed before would definitely show up now, thanks to the stain. Every imperfection will be sanded down. Now they spray the table with sealant. This protects against variations in humidity, which would make the wood expand and contract and eventually split. Then they sand the sealant to prepare for a coat of clear lacquer. The lacquer plays two roles, one functional, protecting the wood from scratches, one decorative, giving it a mild sheen. To cure the lacquer, all the table components go into an oven at 300 degrees Fahrenheit. This also strengthens the finish. This factory specializes in personalization. You can choose your stain color or two colors for a two-tone effect. You can also select the shape of your tabletop, the type of edge and apron, and of course, the style of table legs. iPods may rule in this digital age, but there's nothing quite like a melody that's mechanically generated by a music box. It's why, more than a century after its heyday, the music box still holds a special appeal. Its musical chimes take us back to another time. A revolving disc, swirling dolls, and luxurious cabinetry. The music box is the original home entertainment system. Today, they make these authentic replicas with computerized tools. They contour gear for the spring-wound motor and then carve teeth into it. This gear is similar to the type used in clockworks. It's a wind-up device. Next, they coil a 20-foot-long strip of steel into a little cast-iron barrel. This is called a spring barrel, and it's the device that stores the wound-up mechanical energy. Once the clutch is installed, it will be ready to spring into action. This circular blade now sculpts the weights that extend from the base teeth of the musical comb. The weights are called leads, and they help produce the low notes. To tune the bass, a technician snips the ends of the leads. She plucks a tooth to produce a note, then measures its pitch with an electronic tuning machine. She adjusts it by clipping off a bit more. This process is critical. It ensures each of the 76 teeth on the musical comb will hit all the right notes. There's a damper for each tooth to quell its vibration. They install these dampers on a rail next to the star wheels, the part that plucks the teeth of the comb to produce notes. The technician aligns the dampers to the star wheels and bolts everything to a cast iron plate called the bed plate. Using a pincers-like tool, he checks the tension of the dampers and makes adjustments. Now he secures the upper comb to the bed plate and turns it around to install the lower comb. Music boxes with two combs instead of one have a richer sound. The technician makes more adjustments to the dampers to ensure a proper gap between them and the teeth of the musical comb. He installs the bar that holds down the music disc while it plays. Then he bolts the motor frame to the side of the cabinet, followed by the winding and disc drive gears. He attaches the spring barrel to the gears. Here, he installs a speed control mechanism for the winding gears. It's called the governor because it governs the speed. He winds the motor to power it up for a test run, and then checks all its parts to confirm the motor operates smoothly. When he's satisfied that it does, it's time to install the musical components, beginning with the soundboard, which amplifies the notes. Next, the bed plate with its double comb assembly is mounted onto the soundboard. He screws support brackets to the box. They'll prop up the musical disc. He checks the setup with the dummy disc. On a real disc, music is printed in the form of perforations. This master disc serves as a template to punch holes in a copper-plated disc below. The punctures form curls in the underside of the disc, and it's these metal curls that will set the music in motion. As the wind-up motor turns the disc, those curls snag the star wheels. The star wheels, in turn, pluck the teeth of the musical comb. The music isn't digital, but it's truly magical. The music box is one technology that stands the test of time. So much for feeding Fido scraps from the table. Today's pet food is the stuff of sophisticated nutritional science. It's about protein, carbohydrates, vitamins, minerals, a well-balanced diet. Want to bet some dogs and cats eat healthier than their owners? The formulas for dog and cat food differ because dogs and cats have different nutritional requirements. Cats, for instance, need more fat and protein in their diet than dogs do. But the basic ingredients that factories grind up to make dog and cat food are similar. First, corn kernels. Then cereals, such as barley, wheat, and rice. Workers weigh the ingredients, grind them in a mill, then combine everything in a mixer until they have an even and well-blended powder. A machine called the extruder transforms that powder into bite-sized pieces of pet food. It steam cooks the mixture, then forces it through dies at high pressure. The dies shape it, the way the tip of a pastry bag shapes icing into swirls or roses. Check out this dog bone die. As the continuous stream of shaped mixture exits the die, a spinning knife cuts it into pieces. The company has different dies to produce different shapes. This is a batch of round pieces. Next stop, a hot air dryer for 25 minutes. It heats the pieces to 300 degrees Fahrenheit to draw out the moisture, then cools them at room temperature. Once the pieces exit the dryer, they enter a revolving drum where they're sprayed with fat and flavoring. The fat is designed to add food energy, while the flavoring gives the bland pieces an appetizing odor and taste. Appetizing for pets, that is. The rotation ensures the pieces get coated evenly. From here, the pieces go into storage silos. When they leave the silos for bagging, the machinery screens out any crumbs. The pet food industry has made some interesting observations about the likes and dislikes of its four-legged clientele. Apparently, cats and dogs aren't crazy about food that's too dry, too hard to chew, or too mushy. If the pieces are too small, they'll swallow them whole without chewing and not digest them properly. But if the pieces are too big, they'll gag and get turned off to the food altogether. In the packaging department, automated scales weigh the exact quantity per package. This batch is destined for bags weighing about 6.5 pounds. The package sizes range from just under 1 pound all the way up to 44 pounds. Shelf life is from 12 to 16 months, depending on the formula. Pet food experts say dogs and cats prefer food with a fattier content and a combined meat and cereal formula over just cereal alone. But too much meat flavoring can turn them off. Cats, as a rule, are more particular. They favor more acidic food, while dogs tend to have a sweeter tooth. And you thought kids were fussy eaters. A drum's playing surface is called the drum head. It's the part of the instrument that vibrates, creating sound. Some drum heads are still made the traditional way from animal skin. But a natural skin is very susceptible to temperature and humidity changes, so most drummers today prefer heads made of modern synthetic materials. The drumhead surface is often called the skin because traditionally it was made of calf skin. This synthetic skin is a flexible plastic film called polyethylene terephthalate, the same polyester-based plastic they use to make soft drink bottles. Workers load several sheets of it into a press that applies 75 tons of force onto sharp circle-shaped dies, pushing them upward through the film sheets. The die-cut film circles become the skins. A skin can be made up of just one film circle or several taped together. Workers assemble the layers using a vacuum turntable. The suction keeps the bottom film steady while they apply tape to its outside edge, and then adhere another film on top. Each layer is called a ply. The more plies a skin has, the more bass frequencies it'll produce. Now the skins go onto a computer-guided drill press. The machine drills tiny holes all along their perimeter, about 1/8 of an inch in. The holes are roughly the size of a nail head. They're spaced about 1/4 inch apart. The next machine heats the edge of each film to soften it, then applies pressure to mold it to shape. The skin comes out with a fluted edge, like what you see on a paper cup. This shape keeps the tension even when the musician tightens the skin to tune the drum. Meanwhile, this roll-forming machine uses a series of pressure rollers to gradually shape an aluminum strip into a hoop. The hoop will hold the skin tightly over the drum's body, called the drum shell, creating the tension you need to produce sound. This machine also imprints tiny dimples onto one side of the strip. When the factory later glues together the skin and hoop, this rough texture will improve the bond. Now the machine folds the edges of the strip inward to create a channel on the inside of the hoop. That's where the glue will go. Once the machine finishes forming the hoop, a small built-in circular saw cuts the end. A worker then loads each hoop onto a rotating soldering jig, positioning the ends together. The rest is all automated. A glob of silver solder on the joint. Then natural gas torches fuse the hoop closed. After water cools off the hot metal, the jig ejects the finished hoop. Drumhead hoops can be as small as 6 inches or as large as 40 inches in diameter. Finally, it's time to fit the skin into the hoop. This is the tricky part because the film must be perfectly level and centered. Otherwise, when you tighten the skin to tune the drum, the short side would tighten before the rest, and that uneven tension would throw the tuning off. So they do this critical assembly step on a specially designed table, placing the skins on circular vacuum fixtures that are perfectly level. As suction holds each one steady, a robotic arm runs glue in the hoop's channel all the way around. The glue drains downward through the tiny holes along the skin's perimeter, then dries, anchoring the skin securely in the hoop. Some drumheads go on to get a textured coating. By adding weight, the coating muffles the higher sound frequencies, enhancing the lower ones. This produces a warmer, deeper tone. It also produces that swooshing sound when jazz drummers play softly with brushes. Once the coating dries, a pad printing machine stamps on the company name. Only about 30% of drumheads on the market are coated. The rest are what's known as clear heads. And that's how drumheads are made. Drumsticks are designed for a life of hard knocks. They're usually made of hickory, which is heavier and sturdier than other woods. Hickory can also absorb a lot of shock, which means a drumstick made from it is easier on the hands and wrists, so the drummer doesn't have to suffer for his music. Hickory drumsticks also have good balance and feel, so it's easier to hit the right note. To make them, automated arms serve up hickory dowels to a 3-bladed cutting device that moves on a rail. As the blades shape the spinning dowels, they form a round tip, a narrow shoulder, and a shaft that gradually widens. They spray each stick with a protective coating. These round blades lob off the stubs, the ends where the sticks were held during their initial machining. It's just a rough trim, and the ends need more work. So they feed them to spinning chucks with blades. The chucks are inside a protective metal housing because they spin very fast, and the blades are extremely sharp. For a demonstration, the housing on one of the chucks has been removed, and they turn it by hand. The chuck usually rotates at 10,000 RPM, but at this slow speed you can see just how it shaves an end into the desired shape. The stick comes out of the chuck with a nicely rounded tip. Now they test the sticks. Each one rolls down steel rails that have been specially aligned. If it rolls straight, it means the stick is straight. But if it wobbles, it isn't and would be impossible to play with. They reject those sticks. Next, a printer embosses the brand name and model number onto each of the drumsticks. Now they sort each drumstick by weight. Even if two sticks have been made exactly the same shape and size, their weight can vary because wood has different densities, and that's something that affects the stick's feel and tone. For example, this drumstick weighs 53 grams, but the next one comes in at 55. Over at another workstation, they're making a different kind of drumstick, a felt-tip mallet that will have a softer sound. They press a wooden shaft into the glue-filled hole of the felt ball. The hole is a bit smaller than the shaft, resulting in a tight bond between the stick and felt head. They do a sound check on the other sticks. Even though they've been sorted by weight, there are still subtle differences in tone. A computer analyzes their sound and matches pairs. It's a bit like a dating game. The unmated sticks go back into the mix, and they try to match them up again. This matching process is critical. If one stick has a different pitch, the sound will be off balance. They assign a numerical value to each pair of drumsticks. A cardboard sleeve holds each matched pair together. From a rough wooden dowel to a sleek drumstick, a process that's designed for impact.